Hello children, so it's really nice to meet you all with the first explanation video. I hope to do it very regularly, like at least 2 or 3 questions per week, and I'll be posting it in my WhatsApp group, and after that I'll give you time of about a day or two, and after that I will reveal the answer through explanation video like this. So I'm putting some effort here so all of you can keep in touch with the lesson, revise the lessons which you have missed, and also the questions I put will be kind of interesting. They will be within the syllabus, they will not be too hard, at the same time they will not be too easy, will be very standard questions. And also the first WhatsApp group is already full, around 260 members are already there. So many students have requested me to start another one, so I'll be creating another one soon so all your friends can join. Let's quickly start with this question. So the question I sent you is actually geometry question, and the main problem in the question is you have to know from which lesson this question is from. Many of you thought this is from parallelograms, but actually this is from a grade 11 lesson, areas of plane figures between parallel lines. So that itself was a challenging thing to find out from which lesson we have to enter this question. So now that I have revealed the lesson, let's see how we can use this and get the answer. So let's focus on the first part first, because I think once you figure out the first part, the second part would be easier. The first part, as you can see, area of triangle BEC. Now I have drawn the diagram already. ABCD is a parallelogram. I did not mark the parallel lines because it will confuse the diagram a lot. And they have said parallel line to BD diagonal is drawn such that it cuts AD at F and AB at E. So I have drawn what is explained in the question. Now I have to show that the area of triangle BEC and DFC are equal. So let's see what are the two triangles they are talking about. BEC, that would be this triangle over here, and DFC, that would be this triangle over here. So at the first glance, I know you might have tried to use congruency. That's a good try, but we don't have enough facts to use that. And secondly, if you think a little bit, these two triangles are not between any parallel lines. If you look properly, they are not between these two, they are not between these two. So they are not between any parallel lines, and they are not having a common base also. To apply the theorem which you studied in that grade 11 first term lesson, the triangles must be between the same pair of parallel lines, and also the triangles must be having a common base. Then and only then you can apply the theorem and you can say the two triangles have equal area. That's a small reminder about the theorem we are going to use. So what do we do? So since both of them don't have a common base and they are not between the same pair of parallel lines, and when you see this and when you are completely stuck without any option, that's the time where you have to think about doing a small construction. Now don't do constructions without any reasons. Now we want to make the areas equal. So since I can't make these two areas equal, I am going to try to create triangles. I'm going to try to create triangles which will be equal to these two triangles and see whether I can make those two equal. That is when I remember, okay, now I have this BEC triangle and it is in between these two parallel lines and it is having a base of EB. So what I am going to do is I am going to construct another triangle which is between these two parallel sides and also which has the common base EB, and if I construct it, I would get the triangle EBD. Now if you carefully look at the two triangles what I have drawn here, if you carefully look at them, that is triangle BEC area and triangle EBD area will be equal because they have a common base which is EB, and they are between the same pair of parallel lines of the opposite sides of a parallelogram. So you have to write the reason. Since I don't have space, I am not going to write it. You write the reason as same base between the same pair of parallel lines. So these two areas are equal, that is BEC and EBD. Okay, fine. I have made up some connection with triangle BEC. Now I am going to try to connect a connection with triangle DFC. So triangle DFC, so they are also, I will have to do a construction and say, okay, triangle DFC. Okay, I'm going to create another triangle which has the same base DF and which is also between the same pair of parallel lines. So if I look at it, I can construct a triangle like this. Okay, so again you have to pay good attention to the diagram, then only you can see that triangle DFC, that is this one DFC, and the triangle I created which is DFB, and the triangle which I created DFB, their areas are equal for the same reason, because now you have to look from this way. Look at this way. I'm talking about these two parallel lines. This triangle is coming between them, this triangle is coming between them, cool, and both of them have the same base DF. So when we apply that theorem in this way, you get that this triangle and this triangle have the same area. So triangle BEC is equal to triangle ABD, triangle DFC is equal to triangle DFB. Now I want to make these two equal. I did not have any way, that's why I found this. Now let's see whether these two have any connection. To check that, I will get rid of the unwanted details, then you will kind of see this. I will erase these red color lines. Those are the triangles we wanted to be equal. I will get rid of them so you can see clearly. Now these two blue color triangles, okay, those are the ones I created, EBD and DFB. Can you see EBD and DFB are having a common base, FE, and they are between a pair of parallel lines which the question has mentioned. So you can tell, now you can tell again, triangle EBD area is equal to, mention the word area, triangle DFB. Again the same reason, for everything it's the same reason, common base between the same pair of parallel lines. So now I have said these two are equal. By axioms, if these two sides are equal, these two sides also must be equal. Therefore you can tell triangle BEC area will be equal to triangle EBD area. That's how you finish the first part of the question. I will erase this and I will start the second part of the question. Hope you all understood this. Okay children, let's start the second part. I want to show triangle AEC and AFC are equal in area. I don't have to use the previous theorem for this, but I have to use the answer I got from the previous part for this. How do I deal this? First thing is, I can tell these two triangles are definitely equal in area. Let's see whether you can recall the reason. Area of triangle ADC, that is this one, is equal to area of triangle ABC. The reason is important. I'm not going to write it here, but you have to write the reason. The reason is the ABCD is a parallelogram and AC is a diagonal. Fourth property of parallelograms you study in grade 10. When you draw a diagonal, the area of the parallelogram is bisected. That means area of ADC equals to area of ABC. Reason, diagonal bisects the area of a parallelogram. That must be the reason. Right. Now I know that those two are equal. And from the previous part of the lesson, we know that the area of triangle BEC, is equal to area of triangle DFC. So I can say area of triangle DFC equals to area of triangle BEC. For this one, the reason is proven because you proved it a little while ago. What I'm going to do is, from triangle ADC, I'm going to subtract the triangle DFC. Triangle ADC, I'm going to subtract the triangle DFC. And in the other side, from triangle ABC, I'm going to subtract the triangle BEC. I can do that because these two are equal and these two are equal. So by axioms, I can subtract them. And when I subtract it, now this is the part where you have to pay attention. Triangle triangle ADC minus triangle DFC. ADC is this full triangle. And from ADC, if you subtract DFC, that means if you subtract this part, you can see what is remaining is the triangle we want, which is triangle AFC. So we get, when we subtract these two, we get triangle AFC's area. And on the other side, from triangle ABC, This is the triangle ABC. From that, when I subtract BEC, that is this part, you can clearly see the area of AEC is remaining. So I can say this, when you subtract, you get the area of triangle AEC. Now you have got what you want, that the two areas are equal. Make sure you mention the word area in both sides. So that's how you show the second part of this. This is a above average geometry question. If you have got the answer for this fully correct with the steps and everything, you are already ready for an A. If you can somewhat, understand the explanation and you did somewhat of the question as well, that means you're in a good level in geometry. So don't get disappointed if this was too hard, as this is the beginning question. I just wanted to put a good question out there. There will be more and more questions from different lessons. So hope you all will stay tuned in the WhatsApp group as well as in the YouTube channel. For the second WhatsApp group, do invite the friends who could not join the first one. Hope you all enjoyed the lesson, children. Next question will be posted tomorrow, and another explanation video will be coming soon. You can always give me the feedback about the good and bad of the videos. So see you all around. Best of luck.